Okay, so this is the second section from chapter 2 on the changes in state. So we talked about different states of matter in the last one, so solids, liquids, and gases, and this is how we go between states of matter, because any pure substance can change from a solid to a liquid to a gas. It just depends on what temperature they're at. They have very specific temperatures in which they go from one state to the other. But basically talk about how does this happen in general. So for the first one, we're going to talk about changes between solids and liquids. So if we're going from a solid to a liquid, we means we're melting it. So we're taking something that's a solid and we're making it into a liquid. We call that melting. And so when a solid melts, the particles of the substance are vibrating so fast that they break free from their fixed positions. In the picture over here, you can see these are in a very fixed position, but then once we melt the silver, they're pouring the liquid silver out here, you can see that the particles are moving past each other, which is what liquids do. So basically what happens is you start to heat up particles. Okay, so if I'm going to heat up something, I'm going to put it over a source of heat. As it gets hotter, the particles kind of start to vibrate a little bit. They're already vibrating to begin with. Solid particles do vibrate just a little bit. But then as they get hotter, they vibrate a little bit more. And then they vibrate a little bit more. And they're moving faster and faster and faster. Well, at a certain point, they basically kind of break apart from each other because they're moving they're to the point where they're moving fast enough that they can break apart from each other. So once they move to that point, they become a liquid. And liquids means that they're constantly moving past each other. So we've heated them up. When you heat something up, we basically add energy to the particles. When we add enough energy to a particle, we can get it to go from one to the other. There's a specific point where they do begin to melt. It's called the melting point. And pure substances have a very specific temperature at which they do that, from when they go from that solid to the liquid. So for instance, water freezes at 0 degrees Celsius. Once I go over 0 degrees Celsius, the ice cubes or whatever begin to melt. So that's a very specific point where we call that the melting point. And every pure substance has a known melting point. Okay, so more changes between solid and liquid. The opposite, we're going from a liquid to a solid, we call that freezing. Okay, so freezing means that we're taking something that's liquid and we are going to cool it down to the point where it becomes a solid. So again, the particles of liquid are moving past each other, and they're moving past each other quite frequently, and they're moving pretty fast. Well, as you start to cool them down, anything that kind of cools down kind of stops moving as quickly. Stops, kind of slows down a little bit. And eventually, it slows down to the point where it stops. And it stops at a certain point, and it basically hangs on to the particles next to it and becomes a solid. So you can see in these pictures down here, they're moving past each other, they're moving past each other. You put them in the freezer for a certain amount of time, which is below that freezing point of water, and they come into these solids, which is solid ice. So the particles basically kind of stop moving, they slow down, they slow down, they stop. And they're put into a very solid position where they're connected to each other. And so now we have solid water. So we have what we call a freezing point in this case. And all our pure substances have a known freezing point as well. When will they change from that liquid into a solid? Very specific point for that, very specific temperature. Okay, so our next change of state goes between liquid and gas. So we went from solid to liquid or liquid to solid, and now we're going from liquid to gas or gas to liquid. So vaporization is that change from a liquid to a gas. In general, it's called vaporization. There's two different types of vaporizations, evaporation and boiling. And those are they're both the same. We're going from a liquid to a gas, but they do it in very specific ways. So basically, when a liquid goes to vaporization, the particles in the liquid speed up even more. So we know that liquid particles are moving past each other constantly. But once they start to heat up even more, they get to a point where they can jump off of the liquid and become a gas. So they're basically moving around. Well, at some point, they get enough energy that they basically come off and they become part of the gas state. And this is happening with boiling and with evaporation. Evaporation is a very specific type of vaporization where it just comes off the top layer. So for instance, if you've ever seen a puddle outside, and you notice that it shrinks a little bit, and shrinks a little bit more, and shrinks a little bit more to the point where the puddle goes away, that's evaporation. So one layer at a time, those liquid particles on the top gain enough energy that they jump off that puddle and become part of the gas, which is above it, like the air. Whereas boiling, basically vaporization is happening throughout the entire liquid itself. So you can see there's particles all over the place here. They're basically being heated evenly throughout. And when that happens, any particle that comes near the top is just going to jump off. So boiling is constantly moving around the particles, and eventually they jump off that liquid and become part of the gas as well. So there's another change in state. Okay, so here is a change between liquid and gas as well, but this is going backwards. We're starting with a gas and we're going to a liquid. So this happens when the particles in gas lose enough energy to form a liquid. You probably have seen this after you take a shower and you come out of shower and you see that the mirror or any glass surface definitely is covered with like a fog, or you've ever like blown on a mirror on your glasses or something to clean them and you see that fog develop. That is what we call condensation. So condensation basically, we have a gas, but it cools down just enough that it becomes a liquid, and that's what that fog is. It's that gas basically changing from, you're kind of seeing the gas change into a liquid in that case. That's what that fog is. That's what fog is in general. It's basically suspended water particles that are kind of going from that gas state to the liquid state. And it happens because they're cooling down. So all those gas particles are moving around, well, they kind of slow down a little bit as they cool down, and they kind of jump together. And when they jump together, they basically form that liquid again. So they form liquid particles, and that's what condensation is. So it's that change between liquid and gas. So kind of repeat what we've gone over so far. We've gone from melting. Melting starts as a solid, becomes a liquid. If we go opposite of that, we're freezing. We take a liquid and we become a solid. The two things for gas are vaporization and condensation. Vaporization means that we are starting as a liquid and we become a gas. To go backwards from that state, we condensate, or we go through condensation. So those are the 4 changes in state. There's one more change in state as well. Okay, so this is our last change in state. This doesn't happen very often, but it can happen. Sublimation basically happens when a solid basically turns right into a gas. It kind of like forgoes that liquid part of the process, and it just gains enough energy off of that solid, jump right into and become a gas. That happens sometimes during winter. Maybe you'll see that it's really still cold outside, but the piles of snow get like smaller sometimes during the day, and that happens because of sublimation. So those particles that are kind of sitting on top of the snow pile gain enough energy from the heat that's out during the day to not melt, but to just basically sublimate and jump right from that solid into the gas state. If you've ever seen dry ice before, that's a really, really good example of sublimation, because dry ice, basically that fog around it, is sublimation taking place. So dry ice is solid carbon dioxide. Anytime basically any time, it's sublimating constantly. So you see that fog around the dry ice, you're seeing the sublimation take place. It's basically going from a solid into a gas. So you've just basically foregone the whole liquid state and just gone from one state to the next. And so this is your phase changes. This section is done. Again, the reading is up on PowerSchool. The homework is up on PowerSchool as well, or you can pick it up at school, or you can print it off, or you can ask me to email it to you. There's lots of different ways you can do this. And then if you want to hand it back in, you can take a picture of it and send it to me that way, or hand it in at one of the hand-in dates. Enjoy!